Hi friends, today I wanted to discuss about the topic of chemical coordination and integration. So the topic, which is the 22nd chapter in your first PU or 11th CBSE syllabus. So there is a internal environment of animal body which is maintained in a constant state, and this is done by, we also call it as homeostasis, maintenance of internal environment constant. We also term it as homeostasis. So the internal environment is maintained constant by two of them, autonomic nervous system and endocrine system. So you have to remember that homeostasis is maintained by autonomic nervous system in coordinated activities with that of the endocrine system. So if you define what are glands, they are secretory organs. Glands are secretory organs. Now the types of glands are, there are two types of glands: exocrine glands, which are also called as duct glands, and they secrete enzymes; endocrine glands, which are also called as ductless glands, and they secrete hormones directly into the blood. Since they don't have any duct, hormones are secreted directly into the blood. And there is one more variety called as heterocrine gland, which is both an exocrine as well as endocrine gland. An example for heterocrine gland is pancreas. Pancreas functions both as an exocrine as well as an endocrine gland. So their exocrine gland function is secretion of pancreatic juice, which consists of pancreatic enzymes, and their endocrine gland is the islets of Langerhans, where they have alpha, beta and beta cells, and the islet of Langerhans, they secrete hormones like insulin and glucagon. So now, what are hormones? Hormones are also called as chemical messengers or chemical regulators or information molecules, which are secreted in a very small amount, and it has its effect at the target region. So the chemical nature of hormones are, they are organic substances which are very in complexity, and they fall into two major classes. The hormones are of two major classes: steroidal hormones and amino acid hormones. Some of the characteristic features of hormones are, they have its effect at the target organs or tissues, they are specific in their actions, and they are secreted in very low percentage or trace amount. Generally the hormones are measured in terms of ppm, parts per million. So the functions of hormones are, they are going to improve the metabolic activities, they help in maintaining the homeostasis, that is a constant internal condition of the body. They are also helpful for the morphogenic activities, they also help in the mental activities. The hormones also facilitate growth, maturation and regeneration. The secondary sexual characteristics and reproductive activities are also one of the maintenance of this is due to the functions of hormones. The hormones also control other endocrine glands. The endocrine glands that you can notice in man are, pituitary glands is found in sella turcica in the head region, thyroid glands in the neck region, the parathyroid is embedded on the thyroid gland. The adrenals are found, as the name indicates, adrenals. It is at the upper end of kidney. They are almost like cap-like structure above the kidney. The thymus is found on either side of trachea. The gonads are found below the pelvic cavity. The gastric glands, they are found in the wall of stomach and intestine. Pineal glands are located at the dorsal side of brain. The hypothalamus is a region of the brain that controls an immense number of bodily functions. The pituitary gland is also known as the master gland, also known as hypophysis, is a roundish organ that lies immediately beneath the hypothalamus. The pituitary gland is composed of two distinctive regions: the anterior pituitary, which we call it as adenohypophysis, and the posterior pituitary, which we call it as neurohypophysis. Now the characteristics of hormones they have less or more or less a specific role. Like growth hormone can bring about only the growth and nothing else, and the testosterone can bring about the secondary sexual characteristics and primary sexual characteristics in case of male, and they have no other role. So All the hormones have a specific role. The spectrum of action varies with the hormone. Some of the hormones are highly selective while some of the hormones are generalized. They have a generalized functions. Hormones are produced from a tissue or an organ, and they act on a different tissue or organs, that is the target organ, where their activity is at remote rate. Hormones are transported via blood, as we know that hormones are secreted by endocrine glands or ductless glands. They are poured into venous blood. So the hormones are active in very minute concentration, that is in trace concentrations. Only a few picograms, that is 10 to 12 grams, or 10 to the power of minus 12 grams, or a few micrograms, that is 10 to the power of minus 6 grams. The number of hormone molecules per unit target tissue is definite. A hormone in its primary action affects one or a limited number of reaction, and it does not influence directly all other metabolic activities of the cell. There has to be a hormone harmony in our body. If this hormone harmony is not there, if they are secreted more in amount or less in amount, it leads to abnormality. The different types of hormones and enzymes are: hormones, they are produced from glands without any ducts, so they are just a product of endocrine glands, whereas enzymes, they are produced from glands having ducts, and they are exocrine glands. Chemically, hormones can be either proteins, steroids, or biogenic amines. Chemically, the enzymes are all protein polypeptides in nature. Hormones are used up during a metabolic reaction. Enzymes remain unchanged even at the end of a reaction. Hormones are produced in an organ other than they perform their function, that is, they have a target organ. Enzymes are produced in an organ where they perform their function. Hormones are easily transported through blood. Enzymes are not transported through blood, rather they are transported through ducts. So that was the differences between enzymes and hormones. Now the mammalian endocrine system, it consists of organs and tissues. The hypothalamus, pituitary, thyroid, 4 parathyroids, 2 adrenals, 2 testes or 2 ovaries in case of female, thymus, pineal, highlight tissue of pancreas, and hormonal tissue on gastrointestinal tract is the following organs and tissues in mammalian endocrine system. The hypothalamus is a nervous system of the brain which is also integrated with the endocrine system, and they secrete hormone. So we have already discussed about the anterior pituitary gland. The hypothalamo-pituitary axis. Hypothalamus has an endocrine gland. Hypothalamus is a part of the brain, and it consists of gray matter called as hypothalamic nuclei. It forms the floor of the third cerebral vertical of the brain. Neurons of the hypothalamic nuclei, they control the activity of pituitary gland. The hypothalamus is connected to the anterior lobe of pituitary by hypophyseal vessels. The hypothalamic nuclei or neurosecretory cells, they are going to secrete various hormones, and they are all termed as neurohormones, which reach the anterior lobe of the pituitary by means of this portal vessels, that is hypophyseal portal vessels. The neurohormones, they control the secretion of the hormones from the anterior pituitary. These neurohormones are indicated below. The hormones from hypothalamus are GHRH, that is growth hormone releasing hormone, GHIH, which is growth hormone inhibiting hormone, it inhibits the secretion of growth hormone, thyrotropic releasing hormone or TRH, which stimulates the release of thyroid stimulating hormone or TSH, adrenocorticotropic releasing hormone, which stimulates the secretion of adrenocorticotropic hormone, the gonadotropin releasing hormone or GnRH, which stimulates the release of follicle stimulating hormone FSH and luteinizing hormone LH. Prolactin releasing hormone PRH, they stimulate the release of prolactin. The prolactin inhibiting hormone or PIH, it inhibits the release of prolactin. Melanocyte stimulating hormone, it stimulates the secretion of melanocyte So melanocyte stimulating hormone, inhibiting hormone, it inhibits the secretion of melanocyte stimulating hormone. Pituitary as an endocrine gland. Pituitary is a small body about the size of a gram located on the ventral side of the diencephalon region of the brain. The pituitary, it is hanging below the hypothalamus by a stalk called as infundibulum. So the pituitary has three different zones: anterior lobe, or it is also called as adenohypophysis, intermediate lobe, and they have a posterior lobe or neurohypophysis. If you look into the adenohypophysis, it is compact and highly vascular. It is connected to the hypothalamus by hypophyseal portal vessels. The neurohypophysis is connected to the hypothalamus by the nerve fibers. The anterior lobe of pituitary releases 6 hormones which are all proteinaceous in nature, and they control the activity of various other endocrine glands also. Now the hormones of the ADH, that is adenohypophysis, are growth hormone or somatotrophic hormone. It is also called as GH or SDH. It is secreted by the somatotropic cells of anterior pituitary gland, and its general role is it regulates the body growth, increases the length of bones, controls carbohydrate, protein and fat metabolism. This hormone helps in muscles and viscera growth. These hormones also counteract insulin to raise blood glucose levels, etc. The deficiency of this growth hormone or somatotropic hormone causes dwarfism in young people and acromicria rarely in adults, where it is hypoactivity. The excess secretion of growth hormone or STH hyperactivity, that is, it causes gigantism in youngs and acromegaly in adults. So I have already told you that hormone should have an harmony. Either excess or deficient, it is going to lead to abnormalities. The next hormone that is secreted by the adenohypophysis pituitary gland is, or the anterior lobe of pituitary gland, is adrenocorticotropic hormone. It is also called as ATH. It is secreted by the corticotrophic cells of anterior pituitary, and it controls the growth and secretion of adrenal cortex to release glucocorticoids. Now, what are the glucocorticoids that are released? Are cortisol, cortisone, etc. The secretion of mineralocorticoids by adrenal medulla is stimulated to a less degree. So the third hormone secreted by AD, the anterior lobe of pituitary gland, is thyroid stimulating hormone, or it is also called as thyrotropic hormone, or it is also called as thyrotropin. It is secreted by the thyrotropic cells of the anterior lobe of pituitary. It controls the growth and activity of the thyroid gland. It acts on thyroid to release its hormone, that is thyroxine. Follicle stimulating hormone, which is also called as FSH, it is secreted by the gonadotropic cells of anterior pituitary, and it increases the number and size of Graafian follicles in the ovaries in females, and it stimulates spermatogenesis in males. Luteinizing hormone, LH, or interstitial cell stimulating hormone, it is also called as ICH. It is secreted by the gonadotropic cells. In females, it completes the development of Graafian follicles to its secretory stage and brings about ovulation along with FSH. It causes appearance, growth and maintenance of corpus luteum. The luteinizing hormone stimulates the secretion of progesterone from the ovaries. In males, it stimulates the development and functional activity of interstitial cells to produce testosterone. The prolactin or lactogenic hormone or luteotropic hormone, it helps in the growth of mammary glands during the pregnancy, and it also initiates the secretion of milk after the childbirth. So you should remember, they might ask any 4 or 5 hormones of anterior lobe of pituitary gland. So you just can recollect the growth hormone or somatotropic hormone, thyroid stimulating hormone, follicle stimulating hormone, luteinizing hormone, prolactin or lactogenic hormone. Some of the easy hormones to remember, you can write about them. The posterior lobe of pituitary releases the following two peptide hormones. Both these hormones are synthesized in the hypothalamus, and the posterior lobe of pituitary is also called as neurohypophysis. It is more of a storage region or reservoir for the hormones secreted in the hypothalamus. So they are stored there. From posterior pituitary, two hormones that are synthesized from hypothalamus are released into the blood. They are the vasopressin, or it also called as pitressin, or ADH, antidiuretic hormone. So deficiency of this ADH, it causes, or deficiency of vasopressin or pitressin, it causes diabetes insipidus, where the individuals are going to have dilute urination and they lose excess amount of water. The kidneys fail to reabsorb water in the distal convoluted tubule and the collecting tubules. It also raises blood pressure by constricting the peripheral blood vessels. That is the deficiency of the antidiuretic hormone or pitressin, or it is also called as vasopressin. So it is released generally in response to stress and dehydration, but deficiency, it leads to diabetes insipidus. Diabetes mellitus is different, where it is excess accumulation of glucose in the urine, and it is because of deficiency of secretion of insulin hormone. So the deficiency of ADH, hypothalamic diabetes insipidus, results from a deficiency in secretion of antidiuretic hormone or vasopressin from the posterior pituitary. Nephrogenic diabetes insipidus occurs when the kidney is unable to respond to ADH. The major sign of either type of diabetes insipidus is excessive urine production and excessive loss of water along with the urine. The second hormone that is stored in the posterior part of pituitary gland or neurohypophysis is oxytocin, or it is also called as pitosol. It is also an important uterus contracting hormone at the time of childbirth. It also acts on the mammary glands and helps in the expulsion of milk at the time of suckling. It is therefore also known as, oxytocin is also known as milk ejection hormone or birth hormone. It decreases the blood pressure by dilating the peripheral blood vessels, opposite to that of function in case of vasopressin. The thyroid gland. Thyroid hormones are derivatives of the amino acid tyrosine, and they are bound covalently to iodine. So iodine deficiency also results in deficiency of thyroxine hormone. The two principal thyroid hormones are thyroxine, known as T4 or N35 or 3,5-tetraiodothyronine, and triiodothyronine or T3. T4 and T3 you can remember about it as. The thyroid epithelial cells are responsible for synthesis of thyroid hormones, and they are arranged in spheres called as thyroid follicles. The follicles are filled with colloid, a proteinaceous depot of thyroid hormone. Thyroid is found on the ventral side in the neck region of the body. At the base of the larynx, it has two lateral lobes, one on either side of trachea. Cells lining the thyroid follicles secrete two thyroid hormones, thyroxine and triiodothyronine, or which is also called as T3, T4 and T3. Both are iodinated forms of an amino acid called thyronine, and is stored in the form of semi-fluid material, colloid, in the lumen of follicles. Whenever necessary, the hormones are released from the colloid to the blood. What are the functions of thyroid hormones are? They increase the metabolic rate of the body, they enhance heat production, and maintain the BMR, that is the basal metabolic rate. They also promote, the thyroid hormones also promote growth of body tissues. Both physical growth and development of mental faculties are stimulated by it. They also stimulate tissue differentiation. Hence, they promote metamorphosis of tadpoles into adult frogs. The disorders due to thyroid hormone imbalances. Excessive secretion of thyroid hormone or hyperthyroidism, it results in exothalamic goiter or Graves' disease. It is accompanied by the bulging of the eyeball. It is associated with high metabolic rate, heartbeat and blood pressure rises, restlessness, tremors, nervousness, rise in body temperature. All these are due to the thyroid hormone imbalance. Less secretion of thyroid hormone, hypothyroidism, it results in myxedema in adult and cretinism, feeble-mindedness in children. The patient of myxedema suffer from low metabolic rate, slow heart rate, low body temperature and reproductive failure. Administration of thyroid hormones cures the symptoms. For the synthesis of thyroid hormone, that is thyroxine, an important inorganic ion called iodine is needed in the body. Hence the dietary deficiency of iodine, it causes goiter in which the thyroid gland enlarges in an effort to produce more thyroxine. The failure of thyroid hormone secretion in children slows body growth and mental development, and it reduces metabolic rate. The child becomes stunted and mentally retarded. The body temperature, heart rate and blood pressure are lower than normal. The patient is pot-bellied and pigeon-chested and has a protruding tongue. This disease is known as cretinism. It is again due to the deficiency of thyroid. The thyroid gland disorders, that is hypothyroidism, failure. The reasons for hypothyroidism is failure of thyroid gland or very less secretion of TRH and TSH or both, inadequate dietary iodine. The symptoms of hypothyroidism are low metabolic activity, poor tolerance of cold. The symptoms of hypothyroidism are cretinism in children, poor skeleton growth, dwarfism, mentally retarded, dry skin, thick tongue, lethargy, respiratory problems, constipation, neonatal jaundice, myxedema in adult, edema, facial tissues to swell and looks fluffy. Hyperthyroidism, it is Graves' disease. It is also called as exothalamic goiter. It is an immune disease in which autoantibodies bind to and activate the thyroid stimulating hormone receptor, which leads to continual stimulation of thyroid hormone synthesis, edema behind eyes, exothalamus, with more often in females. The parathyroids, they are 4 pea-sized organs clinging to the rare surface of thyroid but are independent of thyroid structurally and functionally. This gland secretes parathormone whose functions are as follows. It regulates the calcium and phosphate balance between blood and other tissues. It inhibits synthesis of collagen by osteoblasts and bone resorption by osteoclasts. It helps in absorption of calcium from the intestine and reabsorption by kidneys. The disorders of these are hypoparathyroidism. It leads to deficiency of plasma calcium. Nerve and muscle action potentials rise, leading to muscle twitching, spasm, etc. And the condition is called hypocalcemia or parathyroid tetany. The hyperparathyroidism, it causes demineralization of bones, leading to their easy fracture and deformation. It may lead to osteitis fibrosa cystica. That is the hyperparathyroidism that you have to remember about. The adrenals or suprarenals, as the name indicates, they are glands which are present above the kidney. There are 2 adrenal glands, one on top of each kidney. Adrenal gland has an outer portion called adrenal cortex and an inner portion called adrenal medulla. Both these parts differ in the nature of hormone produced and also in respect to their functions. The adrenal cortex, it is very important for the animal, and it is removal or destruction will kill the animal. So adrenal gland is very important. It produces 3 groups of steroid hormones: glucocorticoids, mineralocorticoids and sex corticoids. The glucocorticoids regulate the metabolism of carbohydrates, proteins and fats. They also increase the blood glucose level. Example, cortisol, and corticosterone. The secretion of glucocorticoid hormones is regulated by ACTH from anterior pituitary. Mineralocorticoids are produced from the outermost cellular layer of the adrenal cortex. The main hormone in mammals and birds is aldosterone, that reduces the sodium loss from the body in urine, sweat, saliva, etc. by its active reabsorption from those fluids. It also increases the excretion of potassium in an exchange with the absorption of sodium, retains water in the body along with sodium. Thus, it regulates the ionic and water balance of the body. The secretion of aldosterone is stimulated by three factors: a fall in the sodium ions in the plasma of blood, a rise in the potassium ions in the plasma of blood, a fall in the volume of blood itself. The gonadocorticoids, they stimulate the development of secondary sexual characters in males. Adrenal medulla, it helps the body to prepare for stress or any emergency condition. This part of adrenal, unlike cortex, is not so vital for the survival of the organism, and so its removal will not cause death. So the adrenal medulla produces two hormones. They are called as adrenaline or epinephrine and noradrenaline or norepinephrine. Both these hormones act on tissues and organs. They are supplied by sympathetic fibers and produce similar effects. Thus, adrenal medulla and sympathetic system, they work as an integrated unit, and they are known as sympathetico-adrenal system. So insulin, it is pancreas. We have to remember that it is an heterocrine gland. The islets of Langerhans, they are going to produce the hormones, that is insulin and glucagon. So you have to know about these things. So insulin is a protein hormone produced by the beta cells of islets of Langerhans. It regulates the amount of glucose in the blood by converting excess of glucose into glycogen, which is also called as glycogenesis, and it is stored in the liver and muscles. In the liver, around 100 grams of glucose is stored as glycogen, and in muscles it is around 400 grams of it. The lack of insulin or deficiency of insulin, it results in excess glucose in blood, which we call it as hyperglycemia, and it is also thrown out along with urine. This disease is known as diabetes mellitus. Deficiency of insulin or lack of insulin production leads to a disease known as diabetes mellitus. Melita means honey. The functions of insulin, it increases the utilization of the glucose in the tissues and facilitates the storage of glucose as glycogen in the liver and muscles. So thus it lowers the blood glucose level in the body. The insulin also increases the synthesis of fats in the adipose tissues from fatty acids and also from glucose. Insulin reduces the breakdown and oxidation of fats. Insulin promotes protein synthesis from amino acids in the body tissue. Insulin also reduces the breakdown of proteins in the body. Thus, insulin is regarded as an anabolic hormone. The glucagon, it is a protein hormone produced by islets of Langerhans of pancreas, especially the alpha cells of islets of Langerhans. It regulates the amounts of glucose in the blood by converting glycogen into glucose whenever required, especially during fasting or starving. Thus, the effect of glucagon hormone is opposite to that of insulin. Somatostatin, it inhibits the secretion of glucagons and insulin. The insulin disorders are hyperglycemia, high blood glucose level, the breakdown of muscle tissue, loss of weight and tiredness, hypoglycemia, low blood glucose level, hunger, sweating, irritability, double vision. Pineal gland, the pineal gland or epiphysis synthesizes and secretes melatonin, a structurally simple hormone that communicates information about environmental lighting to various parts of the body. It is attached to the roof of third ventricle in the rear part of brain. So the pineal gland functions as a biological clock and a neurosensory transducer, converting the neural information. The thymus, it secretes thymosin, thymic factor and thymopoietin. It stimulates the entire immune system, and thus it is called as, thymus is called as throne of immunity. It stimulates the spleen and other organs which have stopped functioning to function again. Its secretion, the thymus secretion, decreases with advancing age and entirely stops by about 50 years of age. The endocrine functions of gonads. The male gonad is testis and female gonad is ovary. Gonads produce reproductive cells and they secrete hormones which control reproductive organs. These hormones are also called as sex hormones. They start to secrete from the age of puberty or sexual maturity. In female ovarian follicle, it secretes estrogen, which is responsible for the development of female sexual characteristics, and it also regulates the menstrual cycle. Corpus luteum, the progesterone and estrogen are help in implantation and maintaining pregnancy and lactation. Relaxin, it relaxes pubic symphysis to dilate the uterine cervix. Inhibin or actin, it is going to inhibit or activate FSH and GnRH production, gonadotropic releasing hormone. The placenta, the human chorionic gonadotropin is released, which stimulates the progesterone release from the corpus luteum and maintains it. The human placental lactogen, it stimulates the mammary growth. Testis, testosterone, which is responsible for the development of male sexual characteristics, and it also stimulates spermatogenesis, that is development of sperm. Or inhibin or actin, it is responsible for either inhibition or activation of LH and FSH production. The gonads, disorders of the gonads are in males hyposecretion. It leads to unicoidism, prostate, seminal vessels and penis remains small, infertility, no secondary sexual characteristics. Gynecomastia, that is development of breast tissues in males due to increased estrogen during pregnancy and puberty. In females, infertility, poor development of secondary sexual characteristics. Pineal gland. The pineal gland or epiphysis synthesizes and secretes melatonin, a structurally simple hormone that communicates information about environmental lighting to various parts of the body. Hormone from heart. The atrial wall of our heart secretes ANF, that is atrial natriuretic factor, when the blood volume and pressure in the atria increases. The hormones from kidneys are the cells of juxtaglomerular apparatus. It produces a peptide hormone called as erythropoietin, which stimulates the formation of RBCs or erythrocytes. The hormones from gastrointestinal tract are gastrin. It is secreted by the mucosa of pyloric stomach and duodenum, which controls the secretion of gastric juice by the gastric glands. Secretin, it acts on the exocrine region of pancreas and it stimulates the secretion of water and bicarbonate ions. CCK, which is also called as cholecystokinin, it is secreted by the intestinal mucosa, which acts on pancreas and they secrete pancreatic enzyme. It also acts on the gallbladder to release bile juice into duodenum. The gastric inhibitory peptide or GIP, it is secreted by the mucosa of duodenum, which inhibits gastric secretion and mobility. The molecular action of hormone, steroid hormones. The lipid soluble hormones can enter the cell through the bilayer of phospholipids and interact with intracellular receptors to regulate gene expression. The peptide hormones are water soluble hormones which interact with surface receptor. For example, insulin hormone has a surface receptor which is a heterotetrameric protein consisting of 4 subunits. Of this, 2 subunits protrude from the surface of the cell and binds to the insulin, and 2 beta subunits span the membrane and protrude into the cytoplasm. The 5 steps in the hormone action are binding to the receptor, use of the second messengers or the mediators, amplification of signal, antagonistic effect, and synergistic effect. These are the 5 steps in the action of an hormone. So thank you all. Hope you have liked and enjoyed this video. It was a little detailed part of it and more of theoretical part of it. Kindly go through it again, and I do believe that it will help you to understand better. Thank you.